Okay, so we're going to look at multiplying different types of polynomials. We're going to start off with a binomial times a binomial. Now, over the weekend when we were multiplying, we had a monomial that we distributed. Sometimes we distributed the monomial through a binomial, sometimes a trinomial, all different things. Same process here. We're just going to distribute it a little bit differently. So on the first one, you notice we have a binomial that we're distributing through a binomial. We just take one term at a time. We're going to look at the 2x. We're going to distribute it through. So what is 2x times 3x? 6x squared. And 2x times positive 4. Positive 8x. So we took this term and distributed it completely through the second polynomial, which in this case was a binomial. Now we're going to take the second term, which is a positive 1, and we're going to distribute it through. So we get 1 times 3x is 3x, and 1 times 4 is 4. So when we combine our like terms here, we get 6x squared plus 11x plus 4. Now, this method works for all multiplying through polynomials. Distribute each term at a time through the following polynomial. There is a mnemonic that's used just when you multiply binomials. So this is just for multiplying binomials. And I'll show you it's actually what we just did. Binomials. Okay. And the mnemonic is FOIL. Have any of you ever heard of FOIL? No. Okay. Well, FOIL in this case represents multiplying our first terms. F is for first. Did we multiply the first term in this binomial times the first term in that? Is that what we did? Mm-hmm. Yes. O stands for the outer or outside terms. Did we multiply the outside one here with the outside one here? 2x times 4. Yes, that's what we did. I, what do you think it stands for? Inside or inner. Did we multiply the inside terms next? 1 times 3x. And L stands for last. Did we multiply the last term in this one times the last term in that one? 1 times 4 is 4. So that's a little mnemonic that helps you remember how to multiply binomials, but truly we don't need it because we're just distributing. You try this one. I'm going to walk the room. If you have any questions, let me know. When we distribute the 3n through, the 3n times 5n is 15n squared. The 3n times the negative 1 is negative 3n. Now we're going to distribute the second term through. Positive 2 times 5n is positive 10n. And positive 2 times negative 1 is negative 2. So when we combine our like terms, this simplifies to 15n squared plus 7n minus 2. We're good? Okay. Now, let's take a look at a binomial times a trinomial. Same idea. Except this time, each term of the binomial has to be multiplied by all three terms in the following trinomial. So if we did the 3x times the 4x squared, 3x times 4x squared is going to give us 12 what?
X3.
Good. 12x cubed, or 12x to the third. Correct. 3x times negative x. Negative 3x squared. 3x times a positive 3. 9x. So now what we've done is we've taken this first term and multiplied it through every term in the following trinomial. Now let's take the second term, 2. Positive 2 times 4x squared is 8x squared. Positive 2 times negative x is negative 2x. And positive 2 times 3 is 6. So then we'll look for like terms if there are any. I see I have some squared terms and some linear terms. And so I'm going to add like terms. Negative 3x squared and positive 8x squared simplifies to 5x squared. Positive 9x and negative 2 is positive 7x. Now, sometimes we have like terms and sometimes we don't. So sometimes we can combine our terms and simplify our expression, and sometimes it doesn't work that way. Now this one, they put the trinomial first. So what you could do is take this term and distribute it through the 2. Take the middle term and distribute through the 2. Take the last term and distribute through the 2. Or you can think backwards. Okay, let's take this one and multiply it this way through all 3. Let's take this one and multiply it back through this way through all 3. Either way, you should get the same answer. So now you try the next example. This answer is rather ugly, isn't it? There are no like terms. And it doesn't look like there's a nice little order we can put it in either. Now, this one's in standard form. It only has the one variable, so we went from highest degree to lowest degree. even if we went from highest degree, we have 2 that are the highest. Normally we would do alphabetical. So, yeah. So that's a 4th degree, and this is a 4th degree. And then I guess we could do our 3rd degrees. Yeah, there's just no pretty form to put this in. So guys, when you have multiple variables, and there's no real pattern to it, it's not symmetric, it's not pretty. We're going to look in a few in a minute that are symmetric and are pretty, but these are not. So what we would do is we just leave our answer in whatever form we got it in. Yes, Edward?
For the last part, it's like, so it would be negative y times 3x. It's 3xy.
It's negative 3xy. Thank you. Good catch. Okay, any questions about multipliers? All right, we're going to look at a shortcut real quick. And it's when we have a binomial raised to the 2nd power. Squaring a binomial. Well, x minus 4 squared means x minus 4 times x minus 4, doesn't it? Okay, so if I were to multiply this through, I get x squared minus 4x plus 16. Every time I take something and rewrite it twice, aren't these going to match? So every time that's going to happen. So it ends up being double the product of these two. Isn't negative 4 times x negative 4x? If I doubled that, do I get negative 8x? Yeah. And it's going to work no matter what I started with. Let's say I have 3x plus 2 squared. And I write it out twice. 3x plus 2 times 3x plus 2. And I get 9x squared plus 6x is 12x plus 4. If I did this times this, do you see I get 6x? If I double it, I get 12x. So when we square a binomial, whenever you square a binomial, what ends up happening is you take that first term and square it. So in this case, it would be a squared. You're going to double the product of the two terms. We're going to double the product of those two terms. So a times b, I'm going to double it, so it'd be 2ab. And we square the last term, which in this case would be b squared. So you square the first one, you double the product of the two, and then you square the last one. So let's go with that little shortcut. So I have the expression 2x plus 5, and that binomial is being squared. So if I follow this shortcut, if I square the first one, that gives me 4x squared, doesn't it? Because 2 squared is 4, and x squared is x squared. The product of these two, 2 times 5 is 10. That's 10x, isn't it? If I double that product, double 10x, I get 20x. And if I square the last one, 5 squared is 25. All right, let's just prove to ourselves that this works. Let's write it out twice and prove that it works. So if we distribute, we get 4x squared plus 10x plus 10x plus 25. Does that simplify to the same thing? Okay, so here's our little chant that helps us remember. Square the first, double the product, square the last. Hey, square the first, double the product, square the last. Hey, join with me. Square the first, double the product, square the last. Hey, square the first, double the product, square the last. Hey! Wait. Some of your classmates are not participating. One last try. All right, are we ready? Square the first, double the product, square the last. Hey, square the first, double the product, square the last. Hey. We could keep going. It's awesome. All right, so you try these two by squaring the first, doubling the product, and squaring the last. And if you get excited after you get it right, go, hey. No, you may not take it out instead.
Was this double the product? So minus 2 and then double that.
Okay, do the product of 9x times negative 2 is negative 18x. Okay, Friday we were just full of energy and personality. The weekend must have just sucked it out of you.
Our AP teacher posted more work over the weekend. I looked on Saturday and I just finished my AP work, caught up on my AP work for the week, and I looked and I had 2 more chapters, a study guide, and some more notes due. And it was Sunday night. I was just oh my gosh, so mad. I just started shaking. I was no.
But those notes only took
I sort of just gave up and went to bed.
only 30 minutes. Yeah, those notes weren't hard.
The study guide, I didn't read the article.
I just didn't do it.
I did the reading, but I didn't read the articles. It was 10 o'clock last night, and I said no.
Oh, I found out about that Saturday morning.
Yeah,
I did it Sunday morning. I moved to bed this weekend, Miss Willoughby.
It was a tough weekend. Okay. All right, here we go. We're squaring the first term. The product is negative 18x. We double that. We get negative 36x. And we square the last one and we get 4. We square the first term. We get 9x squared. The product is positive 15x. When we double that, we get positive 30x. We square the last one, we get 5. Now, if for some reason you refuse to chant with us and later on tonight you can't remember how to do it, you can always write it twice and distribute. The rest of us will just be faster than you. Yes?
25.
It is! All day long. Thank you.
Dang it.
I said square the last and then I did not do it. Okay. Pascal's triangle. Okay. Even those of you that have just been watching, I'd like you to take notes on this. Leave yourself space. This is cool if you like math. Okay?
Should we write this?
You shall write this.
How much space do you
We have to write this.
I need this much space right there.
Do we need graphics?
Nope. I did it just so I could line up better.
Pascal's trapezoid.
Huh?
How do how much space for that?
Oh no.
Go to the back.
So sad.
Okay, those of you that I taught last year, this was on my door. As you came into the classroom. Okay, so what we're going to use is Pascal's triangle, and we're going to use that as a simplified way of expanding binomials to higher powers. But first we have to figure out what it is and where it came from and see why it works before we can actually use it. So the first thing we're going to look at, when I take any binomial, if I were to raise any non-zero number to the 0 power, what do I get it? 1. So a plus b to the 0 is 1. Just like x plus 1 to the 0 is 1.
we need to write down the x plus 1 part.
Okay. Alright, now the next one is a plus b to the first. But I'm going to look at this. If I do x plus 1 to the first, does raising anything to the first power change it at all? No. So this is just x plus 1, right?
Yes.
What is the coefficient of my x?
1.
1. It's an understood 1. So let's put a 1 up here. And what do I have here? A 1. We're building. Okay, x plus 1 squared. Square the first, double the product, square the last. Okay, so square the first, double the product, square the last. What was the coefficient of the squared term? 1. What is the coefficient of my linear term? 2. What is the what is my last constant? 1.
Do we have to memorize this?
You're going to see why in just a minute why you don't have to memorize it.
Yeah, that's good, because if I have to
Okay.
memorize one, I think my brain might explode.
All right. To do a cube, can't I just do this? This 1 times what I got for the squared? Okay, you can just watch this. Just watch this and you can write down the answer. Okay, so if I distribute the x through, it's just going to change my exponents, right? And then I distribute the 1 through and nothing really changes. So when I add like terms, I get x cubed plus 3x squared plus 3x plus 1. So what are my coefficients? I've got a understood
1.
1, then I've got a
3.
3, then I've got a 3, then I've got a 1. Okay, raise your hand if you see the pattern. Okay, then what do you have? What's the next line? Just tell me the next line.
1, then 4.
Yep.
Then 4.
Nope.
Then 3. Then 5.
We got that far. 1, then 4.
3.
6.
5. 7.
4.
4.
1.
1. What's the next line?
1.
1.
5. 10.
10.
Wait.
5.
I just got lost.
Okay, what's the next line?
1, 6, 15, 20.
Where do you
What is
get
this?
20?
What is this?
You add the 2 right above.
Okay, so some of your classmates saw the pattern faster than others, and that's awesome. It always happens that way. Okay, so when we look at this, we can always find the next line by adding the ones above it. Do you see that?
Was that right?
10 plus 5 is 15. 5 plus 1 is 6.
You were right, Eric.
Okay? And that's how we do it. Now, let's see. This is what we got when we did it by hand a second ago. Right? X plus 1 to the third. Now what we're going to do is the same problem, except we're going to do it using this row of Pascal's. Now this is for a binomial raised to the third power. What do we notice the second coefficient is a 3. If it was the fourth power, the second one is a 4. If it's the sixth power, the second one is a 6. Okay, so I'm focusing in on this line because this problem is raised to the third. All right, I'm going to pull down those coefficients. 1, 3, 3, 1. And this is how we do it without having to go through these steps. We take the first term in the binomial, raise that to the highest power, which is 3. And then the second term is going to be to the 0, because 3 plus 0 is 3 plus, now we go to the 3, and we go back to that first term, but this time we only raise it to the second power. And we take the second term, and we raise it to the first power. 2 plus 1 is 3. Plus, we take that first term and now we're down to the first power. So that second term goes up to the second power. Plus, the first term goes down to the 0 power. And the last term goes up to the third. Now, do you see how this is straight multiplying? There is no distributing in there. You are just multiplying. What is 1 times x cubed times 1? X cubed. What is 3 times x squared times 1? 3x squared. What is 3 times x times 1? 3x. What is 1 times 1 times 1? 1. Did we get the same thing?
Just
Yes.
blew my mind. You got the same thing.
We got the same thing. Yes, Doug?
On the test, would we need to know how to do the Pascal's triangle?
Yes. Because I might ask you to find it to the 7th power. And it would take you a really long time to multiply that all out.
Yeah.
It's a good thing I have a short experience. I need some time.
Okay. So, we're going to do one more together before I ask you to do one. 2x minus 3 to the 4th. So this time, we are looking at this row.
Looks scary.
Okay? So that's where we're going to start. We're going to start with 1, 4, 6, 4, 1. Please write that down. Okay. Okay, we take the first term and raise it to the 4th power. The second term and raise it to the 0. Okay, now that first term gets raised to what power? Third. So the 2x is now raised to the 3rd power, and the negative 3 is raised to the 1st. Plus, I'll move my 6 over a little bit, give me a little more space. The 2x is now raised to what power? The 2nd. And the negative 3 is also raised to the 2nd. The 2 plus 2 makes 4. And then we move on down. The 2x is raised to the 1st, and the negative 3 is raised to the 3rd. The 2x is raised to the 0 power, and the negative 3 is raised to the 4th.
My brain hurts.
Like, I understand it. It's just like my brain just
But I don't
sees a bunch of work and it's like, no more, please.
Okay, anything to the 0 power is 1. So we can kind of take those out because multiplying by 1 doesn't change anything. 2 to the 4th is 16. My desk because my Moby is deciding to die. Okay, so this makes 16, and x to the 4th is just x to the 4th. Okay, this becomes 4 times 8x cubed times negative 3. Do you guys see that this simplifies to that? So, negative 12 times 8 is actually a negative 96. X to the third. Okay, let's do it a different way. Let's say 4 times 8 is 32, and 32 times negative 3 is negative 96. Okay, this is 6 times 4x squared times a positive 9. All right, 6 times 9 is 54, and 54 times 4 is 216. Okay, this is 4 times 2x times negative 27. So that's negative 54 times 4. So that is a negative 216. But this time it's negative 216x instead of 216x squared. And then 3 to the 4th power is just like 9 squared, isn't it? Because 9 to... So it's 81. Okay. You try.
Or go home. What, we just do 2x? Oh.
Okay, what's my string of coefficients?
1, 5, 10, 5.
Okay, please make sure you're actually trying these and not watching me. I'm actually pretty good at them.
Not to brag or anything.
Yeah, after about 20 years, I really ought to be good at it.
If not, we're in trouble.
Hi, you are. Okay, when you're ready, look up. The homework is out of your workbook, page 86. 1 through 10 all, 12